Good morning, students. In the last class, we discussed about all the phyla of gases: Charles law, Boyle's law, Gay-Lussac's law, Avogadro's law, and ideal gas equation. So today we are going to solve the problems regarding those formulas. Okay. So according to Boyle's law, write the formulas first. Or equation. According to Boyle's law, the equation is P1 V1 is equal to P2 V2. To solve the problem I'm telling, okay? Not a mathematical expression, just a formula. Next, Charles law. V1 by T1 is equal to V2 by T2. Okay? Next, Gay-Lussac's law. P1 by T1 is equal to P2 by T2. Next, Avogadro's law. V is equal to K into N. Okay? N is number of atoms or molecules or ions. Next. Ideal gas equation. PV is equal to nRT. Combined gas equation. P1 V1 by T1 is equal to P2 V2 by T2. Okay. And the last one is relation between density and molar mass. Okay. So in the last class I wrote D by M is equal to NR by T. NR by T. Wait a second. M is equal to dRT divided by T. Same. Before what I wrote, very same. Now I will directly wrote equation for mass. Understand? So this is all about the formulas which we are going to observe in this gases or states of matter. Okay. Let's discuss the problem. Problems are very important for 3 mark students. Take down. A balloon is filled with hydrogen at room temperature. At room temperature, it will burst. It will burst if 0.2 bar. It will burst if the pressure exceeds 0.2 bar. Okay. Next, If at 1 bar pressure, volume of gas is 2.27 liter. Okay, up to what volume can the balloon expand? Okay, so this is the question. So students, the first after reading the question, you have to note down the given data. That is the basic thing. Okay. So first you read, a balloon is filled with hydrogen at a room temperature. Here temperature given is room temperature. So remember this is room temperature is always 27 degree Celsius or 298 Kelvin. That is standard. This is room temperature. Next, if the pressure exceeds 0.2 bar, if at 1 bar pressure volume, if at 1 bar pressure the volume of a gas is 2.27 liter. So initially they given students at pressure P1, that is 1 atmospheric pressure, V1 is 2.2 2.27 liter. Understand? At 1 bar pressure, the volume is 2.27 liter. No matter you have to take this one as P1, this one as V1 only, you may take P2, V2. Okay, this pressure belongs to this volume. Okay, again they said what? If the pressure exceeds 0.2 bar, exceeds means what? If P2 is 0.2 bar. 1 atmosphere, so this one is 1 bar, not atmosphere. Okay, from this you have to calculate V2. So students, by knowing this you can easily say it is Boyle's law because we are taking only temperature as a room temperature for both. At room temperature remains constant. Then according to Boyle's law, what is the equation? You have to write according to Boyle's law. P1 V1 is equal to P2 V2. What do you want here? This one V2. So V2 becomes P1 V1 divided by P2. You know how to take. Okay. Next, P1 value is 1 bar pressure. V1 is 2.27 liter divided by 0.2 bar. So you know bar gets cancelled. Correct? So you divide this, you will get 11.35 liter. Understood? 11.25 liter. Do you have calculator? Okay, listen. Another simplification I say. This is 2.27 is there divided by 0.2. So students here, if we take 0.2, if we shift this here, if we shift this point here like 2.0, then I say 0.002 is there, 0.2 is there, 0.0003 is there. Assume. So another one is 2000.1 is there. Okay. So here point is here. What it means? 2 divided by 10. This means what? 2 divided by 10. If here what students? This 10 is 2 divided by 10 means this is 10 to the power 1. Anything to the power 1 is that much only. Okay? So if goes to denominator, from denominator to numerator, then it becomes 10 power minus 1. Understood? Minus 1 represents this points. Or 10 to the power of anything represents this point. Okay? How to change solution? If the point move forward, if the point move forward like this, then minus value it gets. Understand? If point will move, it gets minus value. Here, how many times it is going? 2 point means into 10 power minus 1. This is 2 into 10 power minus 1. Here, point is here. We want this in 2. So 1, 2, 3. This becomes 2 into 10 power minus 3. Understand? Here, point is here. We are shifting 1, 2, 3, 4. That is 3 into 10 power minus 4. If the point shifts forwards, it will get a negative value. Next here, 2000, 20,000 point, so 2000.1 is there. Point is here. Understand, students? If the point move backward, 1, 2, 3. So this is 2 into 10 power 3. That means this tells about what? Sorry. 2.0001 into 10 power 3. Points move backward. That means it increases positive charge. How many points will move? That is the n value. 10 to the power of plus or minus n. If the points shift towards, in the forward, then it gets a minus value. If it is backward, then it is a plus value. Okay. So here this, if you take this one 0.2 as 2 into 10 power minus 1. Okay. This is 2 ones are 2 ones are 2 3s are 2 5s. Right? 2 ones are 2 ones are 2 3s are 6, 1 left, 2 5s are 10. So this 10 raised to minus 1 is here. If it goes to numerator means it becomes 10. Understand? So multiply by 10 means 11.34. This is the simple calculation. If you don't have a calculator also, then you may calculate this. But you have to know the simple mathematics. Addition, subtraction, division, everything. Understand? This is 11.35 liter. That means the question is, at what volume can the balloon expand? So it can expand at 11.35 liter. So at this 0.2 pressure, this is the volume. Understand? So balloon, if it doesn't want to burst, means the volume must be less than 11.35. If it exceeds, then it will burst. Understand? The question is, it will burst if the pressure exceeds 0.2 bar. At the 0.2 bar, volume is this much. So if it doesn't want to burst, means always the volume is less than 11.35. Okay? Next. Next, I'll write the problem and write the given data. I'll give 2 minutes to you to solve the problem. Okay? What will be the minimum pressure required to compress 500 dm cube of air 1 bar to 200 dm cube at 30 degrees Celsius. This is the question. Okay. So what will be the minimum pressure required to compress 500 dm cube of air at 1 bar to 200 dm cube at 30 degrees Celsius? Okay. Next, we want to check what? Pressure. So students, remember one thing. At 1 bar pressure, the volume is 500. Okay. Next, after that it becomes 200. Means volume decreases. When will volume decreases? When the pressure increases. That means you have to get the value more than 1 bar pressure. Then only this will compress to form 200 dm cube from 500 dm cube. You know, if the pressure increases, volume decreases. Like this. If it is a gas, if I compress this, then it will, for example, balloon, you know that. Okay, if you blow the balloon, if you press, it will attain, somewhat it will compress. Understand? If you apply pressure, somewhat it will compress. If you remove the pressure, then it will again gains its original shape. That is what here. So 500 dm cube of air at 1 bar pressure compressed to 200 dm cube. That means the pressure, the P2 or P1, whatever you take, that is more than 1 bar pressure. Understood? Okay. So students, here they given only 30 degrees Celsius means it is the constant temperature. Only the pressure and volume variables are there. This is also follows Boyle's law. So accordingly, first you write given value. P1 is 1 bar pressure. P2 is 500 dm. So thing you have to remember, students, you have to take P1, V1, P2, V2 value exactly. Means here 500 is also there, 200 is also there. Instead of, in place of P2, if you take 200, you will get the wrong answer. Understanding the question is very, very important. Okay. Next, this is V1. P2 is question mark. V2 is 200 dm cube. Correct? So next, according to, I'll give 2 minutes, you will do first. Answer should be written in bar pressure because here it is given in bar. Answer 2.2. So listen, do yourself. P1 V1 is equal to P2 V2. We want P2. So P2 is equal to P1 V1 divided by V2. P value P1 is 1, V1 is 500 divided by 200. 2 zeros get cancelled. That is 2.25 bar. As I told you, students, the big 1 bar pressure here 2.25 means obviously the pressure is greater than 1 bar pressure. That's why volume decreases. Understand? Next. a vessel of 120 liter, sorry, 120 ml capacity contains certain amount of gas. Certain amount of gas at 35 degrees Celsius and 1.2 bar pressure. Okay, the gas is transferred to another vessel. Transferred to another vessel of volume 180 ml, say at 35 degrees Celsius. What would be its pressure? Its pressure. Okay, so students here listen. Here they are not giving volume of a gas, they are giving volume of a container. Here to vessel, volume of a vessel they give. So here one vessel is there, this is 120 ml. So this is closed vessel. Okay. Next another one is big one, that is 180 ml. Okay. From year to year, your volume is more than here. Volume is less. When the volume will be less, when the pressure is more. When the volume is more, then the pressure is less. Okay. So here they are doing what? The gas which is present here. You know, students, gas is the species which doesn't have any volume, any shape, any mass. Okay, so it occupies whatever the container it is present. So it is 220 ml vessel means completely gas is also filled in 120 ml. Okay, so here we are going to take V1 as 120 ml. Okay, the thing is from year to year gas is transferred. Same gas, same amount of gas. From year to year it is transferred. For example, 1 mole of gas is there which occupies 120 ml. Same 1 mole of gas is transferred here. So it occupies 180 ml. That means obviously pressure decreases. So the pressure you are getting must be less than the 1.2 bar pressure. Understand? That is the analysis. Okay? You just do. Here P1 is there, V1 is there, P2 we want to calculate, V2 is there. Okay, so students listen here. In the both the case they give 35 degrees Celsius means temperature remains constant. Okay, next. Here P1 is here. How much P1? 1.2 bar. V1 means 120 ml. Here listen. 120 ml capacity vessel of 120 ml capacity contains a certain amount of a gas at 35 degrees Celsius and 1.2 bar pressure. Means P1 is 1.2, V1 is 120 ml. P2 we have to calculate because they are asking what would be its pressure. Volume is 180 ml. So same, follow the Boyle's law. Calculate yourself. V1 means 1.2, V1 means 120, V2 means 180. Okay, calculate yourself, answer me, I'll say how to calculate easily. Listen. Here, this zeros gets cancelled. 6 twos are, 6 threes are, 3 ones are, 3 0.4. Because 3 fours are 12. After a digit, point is there. So after a digit, we want to put a point. That is 0.4. So 0.4 into 2 means that is 0.8. Okay? As I told you, if the pressure is less, then the volume is more. Initial pressure is 1.2, final pressure is that is 0.8. Obviously, the pressure decreases. Understand? Next. Next one, data. Fourth problem. On a ship sailing in Pacific Ocean. Pacific Ocean, where temperature is 23.4 degrees Celsius. 23.4 degrees Celsius. A balloon is filled with 2 liter air. What will be the volume of the balloon? What will be the volume of the balloon when the ship reaches Indian Ocean, where the temperature is temperature is 26.1 degree Celsius. Okay. So students, here the mention what? Temperature 23.4 and the volume and another temperature. So the relation, they give two temperature values, one volume, sorry, two temperature values, one volume value. Okay. So that means this follows which one? Relation between temperature and volume. At constant pressure, the temperature is directly proportional to our volume. Our volume is directly proportional to temperature. Which law it is? Charles law. Okay. So listen. First you write the given values. V1, T1, V2, T2. Remember students, always if they given this in the degree Celsius, you have to convert this into Kelvin scale. That means you have to add plus 273. Here initially T1 is there, that is 23.4 degrees Celsius. To this you add 273, you get Kelvin, that is the T1 value. Okay, so this is 296.4 Kelvin. Correct? Next, T2 is also the given. How much? 26.1. 26.1 plus 273. So this is 299.1 Kelvin. Okay? V1 by given how much? 2 liter. So students remember here, according to Charles' law, and right here, according to Charles' law, you know that T is directly proportional to V. Means if temperature increases, volume increases. Listen, here T1 temperature is 296, T2 temperature is 299. Whether the temperature increases or not? Increases. T1 value is 296, T2 value is 299. Then obviously, if temperature is directly proportional to volume, means the volume of this V2 must be greater than 2 liter. Understand? If it is like that, then your answer is correct. Compare your students. V1 by T1 is equal to V2 by T2. What we want? V2 we want here. So therefore, V2 is equal to V1 T2 divided by T1. This one, V2 is equal to this is cross multiplication, correct? So V1 T2 divided by T1. Here, V1 is 2 liter. T2 means 299.1. And this one is 296.1. 4. You use calculator yourself, students. You get approximately 299.1 divided by 296.4. Approximately, you will get 1.009. 2 liter into 1.009. Okay? This one is only this much I wrote. So if you multiply this, you get 2.018 liter. Understand? Here it is 2 liter, it is 2.018 liter. That means obviously volume is more. Understand? At 25 degrees Celsius and 760 mm of Hg. So students, this is also a standard value of pressure. 1 bar pressure, nothing but 760 mm of Hg, or 1 atmosphere. Okay, so conversions are there. Remember, 1 bar pressure means that is equal equal to 10 to the power of 5 Pascal. So 1 bar pressure is equal to 760 mm of Hg. These are the standard values. They may give anything, for kilogram, kg, sorry. For weight, gram is there, kilogram is there, ton is there, like that. For pressure, Pascal is there, mm of Hg is there, bar is there, atmosphere is there. Okay? These are the conversions. So you won't bother about it. 760 mm of Hg pressure. A gas occupies gas occupies 600 ml volume. A gas occupies 600 ml volume. What will be its pressure? What will be its pressure at a height where temperature is the temperature is 10 degrees Celsius and volume of the gas is 640 ml. Question. You have first you write the given data. Listen, here the given temperature, pressure as well as volume. Okay? So take here P1, V1, T1, P2, V2, T2. Understand students? P1 is 760 mm of Hg. V1 600 ml. Next, temperature 25 degrees Celsius plus 273 means 298 Kelvin. 25 plus 273, that is 298 Kelvin. T1 value. P2 is there. How much? Sorry, P2 we have to calculate. What will be its pressure? Next, again the given V2 value, that is 640 ml. And the given temperature 10 degrees Celsius means 10 plus 273, that is 283 Kelvin. So let's compare here. What is the relation between pressure and volume? Means if pressure increases, volume decreases. Understand? From here volume is 600, here it is 640. If volume increases means what happens to the pressure? Pressure and volume are inversely proportional. If from 600 to 640 means volume increases, then what happens to pressure? Inversely proportional means it should be decreased. Directly means if it is, for example, listen, P is inversely proportional to V. P is directly proportional to T. What it means? This is inversely proportional means if this increases, this will decrease. If this decreases, this will increase. Opposite. Directly proportional means if this increase, this is also increase. If this is decrease, this is also decrease. Understood? So here, volume is 600, V1 is 600, V2 is 640. Volume increases means what happens to the pressure? Decreases. That means the pressure must be less than 760 mm of Hg. And remember, temperature you consider here 298, here 283. Temperature decreases means pressure also decreases. That means the pressure P2 must be less than 760 mm of Hg. Okay, so which equation it resembles means this is ideal gas, combined gas equation. Combined gas equation. Okay, so this combined gas equation P1 V1 by T1 is equal to P2 V2 by T2. So students, you want this P2. If you cross multiply this, we get P2 is equal to P1 V1 into T2 divided by V2 T1. P1 V1 into T2 divided by T1 V2. Correct? So because listen, we want only P2 here. P2 we want means we don't want T. So here it is. We want V also here. That's what I want. Understand? I'll write the equation first. Conversions you have to know. P1 V1 by T1 is equal to P2 V2 by T2. Understand? So students, substitute the values. P1 means 760, V1 means 600, T2 means 283 divided by V2 640 into which one is T1. T1 is 298. Understand? This zeros get cancelled. This is 4 ones are 4 6 are. This is 4 ones are 4 5s are. If you divide these students, the above multiply this above value becomes 760 into 15 into 283 divided by 298 divided by 16. You'll get 676.6 mm of Hg. This is the value. 676.6 mm of Hg. Understand? That means here 760 mm of Hg is there. As I told you, the pressure should be less than 760. It is less than 760. That means your answer is correct. Understand? So this is all about the problems, and these problems, especially this idea of combined gas equation, will be important for 3 marks. Okay? In the tomorrow's class we will discuss about the remaining things. Thank you.